First thing, if you guys haven't noticed, there's this poll here on Campus Wire. Please make sure that you fill this out so we get an idea of what to do in the class. So far, the majority of you would prefer to be able to submit your assignments until the end of the quarter, but receive no solutions, because obviously if I gave you the solutions, then you could just copy and paste them in. And about a third of you guys would prefer to have like firm deadlines and actually get solutions after they're given. If we go with the top route, if you were still interested in seeing my solution after you completed the assignment, you could stop by office hours and I'd be willing to give you a copy of it directly there. But you can still see what I was doing, but you'd have to have gotten 100% on the assignment first. After the final ends, I guess I could make the solutions available after the end of the quarter too, to see if you see what I wanted to do, but at that point most people probably aren't motivated enough to even give them a glance. So the other thing I should mention is, even if you can submit to the end of the quarter, don't make that seem like you have all the time in the world to get things done. If you're not finishing by the deadlines that I propose, you're probably going to end up getting too far behind in the class to be able to succeed in the rest of it. So the deadlines I give you, it should probably be that day, with a wiggle room of maybe 2 or 3 days to still get things done. But if you're going beyond that, you really need to be coming to office hours and getting the help that you need to be able to succeed in the class. Do you guys have any questions? Yes. Even the midterm you could submit late if you wanted to. Okay. So today we're going to talk about operator overloading. Run through some examples of that, and then we are also going to need to discuss circular inclusions to make sure that they don't happen, so remind me to cover that topic. So operator overloading is the ability to define how the built-in operators, plus, minus, times, etc., behave on your user-defined types. So there's 38 possible operators that you can overload. That's all of them listed out there. There's lots. So even something like parentheses is an operator that you could overload. And there are also, in addition to the ones that are mentioned here, there are casting operators that can be used to create your variable of a particular type to another type. One reason why you might decide to do operator overloading is that it can make your code a little bit more readable than just doing function calls in certain situations. Normally this is going to be true if the class or object you're trying to represent is very math oriented. So you need to be able to add or subtract or multiply or divide whatever your object is. Adding plus, minus, times, etc. on it makes a lot of sense. So things like matrices or fractions or complex numbers or polynomials make a lot of sense to do this for. It doesn't make sense to do operator plus and operator times on every single class. It probably wouldn't make sense to have a tic-tac-toe game plus another tic-tac-toe game, or tic-tac-toe game plus 7. I have no idea what that means, and so probably defining operator plus on it in that situation doesn't make sense. So there are two different syntaxes for how you can define an overloaded operator, and I've actually showed you one for defining the outstream operator for printing out a vector. The first one is inside the class, and inside the class you would say the return type operator. Operator is a keyword, so you'd say operator, and then over here you have the actual operator, plus, minus, times, divide, plus equals, minus equals, etc. When you define it this way, if the function or if that operand has two things on it, you're the left-hand side. So if you're defining operator minus, right, or let's just say operator plus, right, and you do a plus b, you are the a. Or if you define operator times and you do a times b, again, you're still a. If you define something like plus equals, a plus equals b, you are a. This is a. Does that make sense that you're the left-hand side in those statements? There are also unary operators, like unary minus. Unary minus is negate. So if you say negative a, you are negative a, and you'd want to return a copy of yourself, but negative. The other way that you can do it is you can define it outside of the class. So you say return type operator, again, the actual operator plus, minus, times, and then arguments. We'll talk about friendship a little bit later on, but you can make these operators friends so that you get direct access to the private member variables. And then, you'll have, if you have like a 2 operand function like a plus b, it's very clear who a is and who b is. Or if you have like operator plus equals, the first operator is the left-hand side, second operator is the right-hand side. So over here you can see we have a class called complex number, like we defined before, but we might want to do like plus equals, right? So here's plus equals defined inside the class, right? I am this, so I'm a plus equals b. I want to change myself to have b added to myself. Or you could also define it outside the class. This is how you would make the operator a friend, which we'll talk about friendship in a little bit. But operator plus equals, this would be the left-hand side and right-hand side. So this is left-hand side plus equals right-hand side. Any questions? So if you want to call the overloaded operators, there's 2 ways of doing it. You just now can do plus equals or times equals or minus equals or whatever way you've defined it. And it'll work. Or explicit, you can call it by name. So, right, we can do f1 plus equals f2, or we can do f1 dot operator plus equals f2. Or if it was defined outside the class, operator plus equals f1 comma f2. Normally, if you're writing overloaded functions or overloaded operators, right, you're doing it so that you can do it in this version, which I think reads a lot easier than these other 2, but are equivalent. And notice that when you do like this f1 plus equals f2, it really does get translated into a function call, right? We call some function that we said to do that we want to run when this happens. Sometimes there are both unary and binary operations of certain methods. For example, right, you can have star var or var times var or negative var or var minus var. So you might be curious, well, how do I specify which version I'm doing? The way that you specify it is by the number of arguments that operator accepts. If you're inside the class method and you want to do the unary version, your function would accept 0 arguments because you're implicitly negating yourself or dereferencing yourself. If you wanted to do the binary version and you were inside the class, you would receive that one other operator, the right-hand side. If you were defining the function outside the class, the unary version will receive 1 argument, and the binary version gets 2 arguments. All right, so this is operator minus for a negative sign. This is like negate, and this is operator minus for doing subtraction. So myself minus the right-hand side, or again doing it outside the class as well. So technically, these should probably be something like complex numbers because you get a brand new one. Any questions here? Yeah. They don't have to be friends. So we'll get to friendship in a minute, or we can talk in 1 minute, but you don't have to be friends to be able to implement these operators outside the class. What friendship does is friendship makes it so that you have access to all of the other classes' private members. If you don't need to access any of the private members, you don't need to be a friend. One other thing that you might be interested in is there's pre-increment and post-increment, like plus plus A and A plus plus. How do you specify the different versions? So the pre-increment versions, they receive no arguments. So operator plus plus, that's the pre-increment. If you want to do the post-increment version, you put a dummy integer variable in there. So the function receives an integer. It's not actually going to get anything there, but this is how we know that it's going to be the post version as opposed to the pre version. The parameters to an overloaded type can be anything else. They don't have to just be the same thing as your class. So if you want to be able to add complex numbers and integers, you can define a plus for that. Or if you want to be able to add complex numbers and floats, you can define a plus for that. So the thing on the right-hand side can be of some other arbitrary type. And you can see, again, both inside the class and outside the class. Again, define this if it makes sense. But one question you might have is, what happens if I want the thing on the left-hand side to be my type, right? What happens if I want to be able to do integer plus complex number? Well, if you want to be able to do that, the operator has to be defined outside the class. Because if you remember, when you define it inside the class, who is implicitly the left-hand side argument? A complex number, right? You are the left-hand side of that operator. So it always would have to be, like right now, complex number plus integer, complex number plus float. If you try to do float plus complex number, it wouldn't know how to do it, even though, technically it's probably not too difficult to make that happen. So if you want to be able to do it in that other order, you have to define it outside the class. This is option number 2. Option number 1 is, I guess technically you could have the other class define what should happen, but for some classes it's not possible, right? I can't change how the integer plus is a complex number because I don't have access to the int class, right? Or the vector class, or the string class. I can't change what's inside of it. So you're probably always going to have to reach for option number 2, right? Define that method outside the class. So here's complex number operator plus an integer, the left-hand side, right? The right-hand side is now the complex number. Operator plus the float is the left-hand side, and the right-hand side is the complex number. Yeah? Can you say that again? So like the two-string method? So right now, plus is already overloaded on strings. So you can directly do string 1 plus string 2 because the string class has overloaded operator plus on it to do concatenation. One thing that you can think about to save yourself having to write a lot of code, like redundant code, is you can implement the op equals version of that function and then just call it inside the op version. So if you had to do like plus equals, minus equals, times equals, but you also had to do plus, minus, times, and equals, you can get plus, minus, times, and equals for free as long as you did the plus equals versions to begin with. The assumption here, though, for this to work is that your object is copyable. So, for example, over here we might have our complex number, operator plus, right? We add the real parts together, and we add the imaginary parts together, right? And then we're going to return a reference to ourselves, right? Complex number reference. The reason for returning a reference to ourselves is so that you can chain the operators, so that you can do like A plus B plus C. Because if you didn't return something, right, you do A plus B, that's a function call, and then that doesn't give anything back, so how are you supposed to do the plus C? It wouldn't work. I can draw that on the board in 1 second. But then over here in the complex number itself, right, the plus version, I can copy myself and then just call the plus equals in the copy. Copy plus equals the right-hand side, and then return the copy. What I was alluding to just 1 second ago is this. Right, so we have A plus B plus C. If we wanted to write this, because these are instances of our class using the operator calls, it's going to be A dot operator plus B dot operator plus C. That's actually how the compiler views it, right? So notice we do A plus B first. This yields the new result, right? So it has to return something in order for us to do the dot operator again. Does this make sense? Why we have to return something from our objects? Otherwise, you couldn't do the chain. If our complex number over here, for example, like only returned like void, we could add two things together, but we couldn't add three things together. Or oddly enough, you can do things like this. That's completely legal in C, though probably not something that you want to be writing because it's weird. Right? So first we would do A plus B, store the result back into A, and then use that entire sum as C. So if A was equal to 10, B was equal to 100, and C was equal to 5, what would the results of, what would the values of A, B, and C be after you did this expression? So what would A be equal to? B be equal to? C be equal to? And then we should probably say something like this. And what would D be equal to? So what's A going to be equal to? 110. B is going to be equal to 100, right? We didn't change it. C is going to be equal to 5 because we didn't change it. And D is going to be equal to 115, right? Because this expression evaluates to, here we do A plus equals B, right? So A evaluates to 110, and so this expression right here evaluates to 110 as well. But you can write some really weird stuff in C and C++ and have it still be legal. So that's why we're turning like references back here, so that if I wanted to be able to do something like that with my complex number, I totally could. The other final thing that I should mention is you should make it so that your functions behave in a way that makes sense, right? If I do A plus B, do you expect B to change? No, right? And you can see over here in my operator plus what I receive. A const reference. So could I change B? Could I change the right-hand side? No. But if I got rid of this const right here, would I be able to change the right-hand side then? Yeah, you could, and it's still completely legal C code, but anybody using your code is probably going to be confused as hell when they add A plus B and B changes, right? So don't surprise anybody and make weird things happen. You guys have any questions here? Okay. So we are going to write a new class, which I need C line open for. And we are going to implement a polynomial. And we're going to define like some plus and minus operators on it, as well as an operator parentheses to make things happen. This will also help us answer the question that was asked quite a while ago, is how could I write a function that removes all of the duplicates from a vector? Sound good? Do you guys all know what a polynomial is? In case you weren't aware, that's something in the form that's like a times x plus bx squared plus cx cubed, right? Some of those things could be missing. And there are also other examples online of doing things, like with the complex number is a pretty simple, straightforward one. There's also ones with doing fractions. So do take examples, or take a look at the examples there if you're confused on, are still confused after today. I want a new project. I guess we didn't actually have one for the complex number. Okay, so we're going to let this build for a second. I should get up there in a second. Okay, so we are going to create a new class. Polynomial. You guys have one question for you. How many of you guys found the homework difficult? Yeah. It's supposed to be challenging. How many of you guys took my advice and wrote the Python versions of the assignments as soon as you were able to and didn't wait and just do it purely in C? Did it help? Someone, because at least you had the idea down. So I promise you guys this class is going to take a lot of time, and it's going to. So do start early. So how should we represent our polynomial? Should be the first question. Probably not as a string, but we could eventually have it print out as a string later on. So we will define the overloaded operator for printing on it in a little bit. Yeah. So we could have a vector, right, where each index could represent the position. One downside for that is that we couldn't represent negative powers, right, if we wanted to be able to do it that way. So if we don't want to have negative powers, that would be perfectly valid, though it would kind of make things difficult. Like if we just had a times x plus something like c times x to the 100th, right? You'd have a lot of blank space of 0, 0, 0, 0, 0, 0, 0, 0 along the way. I think I heard it. You could use a map, right? What would you have as your key? The what? Like the order, like the power, right? The key could be the power, and the value could be, I don't know what that, the constant, the scalar thing that you multiply, the a, b, c, the coefficient. Thank you. So we'll probably use that approach. So we'll have we need to include map to be able to use this. So we'll have an std : map. Our key type is going to be int. Well, assuming we're not allowing fractional powers like 0.5, right? We'd have ints. If we did want to allow fractional powers, we could use doubles. And our coefficient type should be probably double, right? Because it makes sense to multiply it by a scalar. And then we might have something over here called coefficients. We will do code, and we will generate a destructor. Don't forget to do this. It probably won't break things now, but it'll start to break things later if you forget. It just needs to be empty at the moment. So right now, we might have a couple of different ways of creating a polynomial. So how does it make sense to create a polynomial? Does an empty polynomial make sense? Sure, it would represent what value? 0. Right, so an empty polynomial makes sense in terms of what we have to do here. We don't have to really do anything because our member will be initialized using its default constructor. So what we could end up doing here, because if we didn't want to bother writing it, we could just say equals default. Use the default one. Any other ways that make sense? Yeah. So one thing that we could do is accept a vector of doubles as was proposed before, like if we wanted to have only positive ones. So we could accept a vector. Oh, the other one that we also probably want to accept is a map, and we probably also want a copy constructor. So those three things make sense. So we are going to need to include vector. And we will then have the default one. We'll have polynomial where we get a const std : vector of double called coefficients. And then we'll also probably take another const std : vectors. these ones should be references because we don't want to copy the elements coming in. Also called coefficients. So we'll start with the easier of the two, which is this guy. And so what should we do over here for this constructor? Yeah. Yeah, so we would just do coefficients, coefficients. Right? But remember, this coefficient is my member variable. This coefficient is the argument. Right? So we call the copy constructor on the map. Mm-hmm.
Of the argument that we're providing or any.
You could set other ones too, right? And you'd want to make sure that all of your members are initialized to something, right? Because remember, if you don't explicitly initialize them, and they are a like a built-in type like double, float, or char, their value will be uninitialized and undefined. If it's any object type, it will be initialized using the default constructor, assuming that exists. So now over here, how do we do this one? Hint, this is one of those times where we can't just do it in the body. I mean, we can't do it in the initializer list. So we're actually going to have to go into the body and do some work here, because there is no constructor that we can call to make the magic happen. Yeah. Yeah, well, because we're going to assume that the one at index 0 is like times x to the 0. The one at index 1 is times x to the 1. Index 2 is times x to the 2. Yeah, we have a loop. So what's our loop going to look like? So for const auto reference Kirchhoff and coefficients. Yeah, coefficients. You might also have to have like this, like int power is equal to 0. Then what do we do? So we have to say like our coefficients. So how do I distinguish between this coefficient and my member variable coefficients of the map? Right? This arrow coefficients dot insert, and we want to insert a new pair where the key is the power and the value is the current coefficient. So what the curly brackets mean, like when you're using them as a constructor call, are context sensitive. So here, because insert can accept an initializer list, or it can accept a pair, it knows to call the pair constructor to pass into the insert. Yeah. Yeah, and we'll need to also increment the power. So this is something that actually has to be done inside the body of the constructor and cannot be done inside the initializer list. So you're finally seeing an example of that happening. Are there any questions about these methods? Yeah. So this is you. So if you've done Python before, this is self. It's the same thing as self from Python, but it's called this in C++. And unlike in Python, where you can actually name self to be anything you wanted, in C++, this always is this. And it's a pointer to yourself, and we will discuss pointers probably next week. Like, we're going to take that whole week. But any questions here on constructors? So what things would we like to be able to do with our polynomials? Probably add them together, right? Subtract them. Maybe negate them. Doing the multiplication is like a little bit trickier, but you could do it right because you have to go and like multiply across, and then you're going to get like new powers. So we could try to do multiplication if we have time, but the things that I want to do right now are plus are plus equals, plus, minus, negate, and printing. Sound good? Okay. So the first thing would be, like, we might want to, like, generally when I do the operators, I like to do most of them outside of the class. So we will do them outside the class, but we can also do a mix to make sure that you can see how both are happening. So let's say we do operator plus outside the class, and we're also going to do operator plus equals. So the plus equals would be something like polynomial operator, right? That's our keyword. Plus equals. Our left-hand side of the plus equals is going to be a polynomial, right? So a polynomial reference, remember, because we need to change ourselves, left-hand side. And then the right-hand side is going to be a const polynomial reference, right-hand side, because we shouldn't change the right-hand side. Does that make sense? And again, notice this is outside the class. Okay, so how do I add two polynomials together? All right. So if they had the same power, what happens to their coefficients? They get added together, right? What happens if the coefficient on the right-hand side doesn't appear in the left-hand side? Right? You just copy it over into the right-hand side. So we need to go through each of the elements, right, of the right-hand side polynomial. So how do we do that? For loop, right? So for const auto reference power and coefficient in right-hand side, because remember, when you iterate through a map, you're going to get a pair. What is this complaining about? Oh, oops. Right-hand side dot coefficients. And you can see here's a private member, so I don't actually have access to that, right? This is kind of where like the friendship might come into play. So maybe we should talk about that. It's not that complicated of a topic. Oh, there it was. So first thing is, before we talk about friendship, we need a reminder of why we have protection levels. Again, this is for like data hiding and encapsulation purposes. People outside the class don't need to know how we work internally. We don't want people to be able to mess with our internals because they might break something because they don't know how it should work. By doing this data encapsulation and this data hiding, it provides a very clean interface. We know how we can interact with the object, and we don't have to care how it gets done, right? You've worked with like an IO stream. Did you care how it read stuff from the file? No, but you're just glad that it did, right? Or if you're like in Python, when you or like with a vector, like when you do pushback, do you care how that works? No, but it does it. But you don't need access to those internals to make it happen. Again, it's going to prevent people from breaking things by messing with our internals, and it also potentially makes updates easier because as long as the only thing that we change are the internals, the user code that uses us doesn't need to change at all. It's only if I change those functions that the user is able to call, the public ones, that they're going to have to update their code, and then they'll be angry because they have to go change all their stuff. But there are sometimes situations where only one or a few specific classes or functions need the ability to access some of our private or protected member variables. Again, we need access to those member variables, so potentially we could provide getters and setters to be able to do that. But again, the thing here is we don't want everybody to have access to those things. right? If we make those scatters and setters public, everyone can then use them. But again, we only want to make sure that specific classes are able to use that, or specific functions are able to access those members. So this is what friendship does. When you declare a class as your friend, or a function as your friend, you grant access to your private members for that class to use. The joke that always helps people remember this is friends have access to your private parts. So, right, so if you make somebody your friend, they have access to all of your private members, and then, of course, they always had access to all of your public members, and they will also have access to your protected members. This is going to allow you to give trusted classes or trusted functions access to those things so that they can use them without allowing everybody in the world to have access to them. So if you want to declare a friend, what you do is you say friend, name of that class, inside your class. And that will make that class your friend. That person now has access to all of your private parts. You could also only pick out a particular member or method of a class if you only wanted to make that method a friend of your class. So here inside class A, we say friend class B, right? This is now making B a friend of A. So B has access to all of A's private members. Here we said friend int max A and B. So now the function max is a friend of A and has access to all of A's private parts inside of that function. And if you really wanted to, you can say friend class C : foo. And now this function has access to all of A's private parts, but only that one single function, foo, inside of class C. Everywhere else inside of class C, A's private members are not accessible. One important thing to note is that friendship isn't mutual. So just because you say that someone is your friend does not make you their friend as well. So back here, if I say friend class B, this means that B is a friend of A. B has access to all of A's private parts, but A has no special access to B, right? Friendships aren't mutual like they are in real life. They're kind of like one-directional. So they're very selfish, right? So, or it's very like sad when you have like that the person is like, oh, you're my friend, but then you don't feel that way. Right? That's kind of how C++ is, right? Unless you both declare each other as being friends, the friendship is one-directional, right? B is the friend of A, so B has all access to all of A's private members, but A has, again, no special access to B. Again, it's also not transitive as well. So the friend of my friend is not a friend of me as well. Right? So if I say B is a friend of, or if I say B is a friend of A and C is a friend of B, C is not A's friend. Right? Right? So B has special access to all of A's private parts. C has special access to B, but C has no special access to A. Does that make sense? So again, unless you explicitly say someone is your friend, they are not your friend. This one, we'll come back to this after we talk about inheritance, and that's friendship. Do you guys have any questions about friendship? So now what we need to do back here is, again, we want to access this private member. So what we need to do is we need to make this function our friend. And so what you would do is we're going to have to take this from here and put it inside here, and now we say friend. This function is now our friend. So again, this is just a declaration, right? And pay very close attention, because this operator plus equals is not a member method of polynomial. It's saying that there is a function called operator plus that takes these arguments that is a friend of polynomial. But notice this is not a member of that class. Yeah. This particular one? Yeah. Where it's polynomial plus polynomial? Hmm? you could probably do something like this. But then I don't know what a polynomial is. So then I could say this. I can type. And then, yes, this will now work. This is what's called a forward declaration. And it says this class exists. The end. Right? It doesn't tell you what the class is made up of, or what that class can do. It just tells you it exists. And these are sometimes necessary because of that top-down one-pass compiler nature, or one-pass nature of the C++ compiler. We will have to talk about this a little bit more about circular references. But when you have a forward declaration, there are some limitations to what you can do with that declaration only. If all you have is a forward declaration, you can have a reference to that class. You can have a pointer to that class. You can receive objects of that class as arguments to a function, and you can return objects of that class from a function. So your declarations can, receive arguments of that type or return arguments of that type. What you cannot have are instances of that class, nor can you, you just can't have instances of that class, and you cannot call any members of that class. Yes. Yes. So like this remember, because like when you pound include this file, right, it puts this at the top. So again, imagine now in main this is at the top, right? So again, you'd have to have this exact piece of code copied into main, and it would have to probably exist before your pound include of polynomial, but it should still work. One thing to recommend is, and we're going to need to go back to tic-tac-toe probably this evening and talk about this, about the circular inclusion problem, is that it's better if inside your header file, if all you need are, again, references to that class, or you need to accept those arguments, or accept arguments of that class, or return instances of that class, but you yourself are not directly made up of that thing, do a forward declaration only, and then make the appropriate includes inside your header files. We'll discuss the problem in more detail then, but we're going to keep, programming here. So back over here, I now have access. So we said that we need to figure out if this thing is in ourselves, or actually I should say it's in the left-hand side's coefficients. So how could we see if this power, which I'm also going to do this, const auto reference power is equal to power and coefficient dot first const auto reference cur cof is equal to power and coefficient dot second. This is so I don't have to keep saying power and coefficient dot first, power and coefficient dot second. That's a lot to write, and I think this makes things a little bit easier and user friendly for you. Kind of like if you're from Python and you said like, for a comma b in something, and it pulled both the elements out, kind of the effect we're trying to get here. So how can I check to see if power is in the left-hand side's coefficients? Again, there is no this because we're not a member method, right? We have to say left-hand side. So if the left-hand side dot coefficients dot count, and what are we trying to count? Power or coefficient? Power, because that's our key. So what do we want to compare the count against? What are the possible values the count could take on in the map? Zero if it's not there, and 1 if it is, right? Because remember, the count tells you how many occurrences of that object, or I should say, how many occurrences of that key are in the map. And right, keys have to be what inside the map? The keys have to be unique, so your count could either be 0, it's not there, or 1, it is there. It couldn't appear multiple times. But if you had something like a multi-map, right, what could the possible values for count be? 0 if it's not there, or 1, 2, 3, 4, 5, 6, 7, however many occurrences of that key actually appeared, because the key could appear multiple times in the multi-map. So you guys want to do equals equals 0 or greater than 0 here? Sure, equals equals 0. Good choice. So this means, you know, this power is not in the left-hand side. So what should we do? Just copy it in, right? So what do we use to copy it in? Insert, right? So we do left-hand side dot coefficients dot insert, and we can insert power and coefficient, right? Because we have to insert that pair, so we might as well insert the pair because we have it. Otherwise, right, this power shows up in the left-hand side. The left-hand side dot coefficients dot at power plus equals the current coefficient. Any questions here? Hopefully this makes sense. So now we want to do operator plus itself. Operator plus actually isn't going to need to be a friend. So I'll put it down here. So polynomial. Oh, we forgot to do one thing. Again, we need to return a, this should be a polynomial reference. What should we return after we do this plus equals? Oh, that was cool. What should we return? Cool. I guess this one didn't change. Okay, so we need to return the left-hand side because that's the one that we added to. That's what makes sense to return. Does that make sense? Okay, so then down here we need to have polynomial operator plus const polynomial reference left-hand side, const polynomial reference right-hand side. So how can we do this easily and efficiently? Right, I showed you the trick on the slides. First, we make a copy of the left-hand side. So we have a polynomial called copy. So we copy the left-hand side. Again, copy is not a function. Copy is the name of the variable, right? But I'm using the copy constructor, right? Then what can we do? Left-hand side plus equals the right-hand side. And then we can return copy. Oh, yes, thank you. And ta-da, we're done. Right? This is why doing the plus equals and the plus together makes it really easy to get both. We will continue this tonight. See you then.
being the same?
Yeah, most of it should be pretty similar.
Is that okay? Like,
No, like I expect them to mostly be the same because like the board structure is the same, players are similar, right? A lot of like the main thing that you have to like change to get working is like the winning and the playing of the moves. So yeah, a lot of it's gonna be similar.
So you said that it's legal to pass a 10 to a 3 times 4 board, but how does it work?
Say it again.
You said it's legal to pass, like connect 10 on a 3 times 4 board. Does it mean that you can have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then win?
No. So like if we had like if we said we needed 10 pieces in a row to win, like on a 3x3 board, that's just gonna be physically impossible.
So,
right?
So it's not like as long as they're consecutive.
No, right? It's diagonals.
It's still also diagonals and stuff.
Verticals or horizontals, right?
Okay.
The reason that I have like that kind of constraint there is because it makes it easier for me to test like, are you able to detect tying? Easier,
Okay, right.
because if I make it impossible for me to win, I can just kind of like play randomly however I feel like, and making the test case, and then you'll never win. You can only tie, so that helps me do that.
All right, and also for a diagonal wing, again, it's a 3 times 4 board, which means, and you say if you need 4, say you need 3, right? Which means you can have here,
Right, so you can have a win here,
here, and also
a
here.
win here,
So
or a win here,
there,
and a win there.
yeah. So how this is the where they have the same index, but for this one, how do you generalize the case? Say that it's 0 correspond to 1, 1 correspond to 2, and 2 correspond to 3, right?
So remember, like everything that we did in like tic-tac-toe isn't going to be like directly transferable over to ConnectN. There are some similarities, but there are also quite a bit of differences. So I want you to spend more time thinking on this and how to get it done. Because with the tic-tac-toe, right, pretty much the only way that you could win is if like, because the boards are always square,
Yeah.
right, and you need to complete like the entire thing in a row. So the only main diagonals that would work are these ones.
Yeah.
Right? But here it's possible to actually have a lot more.
Oh, because if you
Even
need
if
only
you-
2, then
Yeah,
you have
like-
a lot more.
Or even if we did something like this, right? Like let's say we needed 3, right? We could have here, or here, or here, or here, right? Or if we had 2, right? There's a lot more, right? There's here, and 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 here. And then also going like the other directions. Right? There's a lot of possible ways that you could win.
So maybe you can check that, say, like a recursion. Start from the cube and check whether it's I plus 1 and the second index plus 1 is a okay.
There
kinda get it, yeah.
There might be a recursive solution. I've never done recursion personally on this problem,
Okay.
but that doesn't mean that there can't be, because any for loop you could write could also be written using recursion instead.
Okay.
Yeah.
My question was kind of similar to his first one, where the consecutive number of pieces you win are not possible. So you will just fill up the entire board until
Then
tie,
eventually
right?
just get a tie, right? Right, but it's not. There shouldn't be a special case like if it's impossible to win. I know I'm going to be a tie, right? You would just end up getting the board full, and there wouldn't be n pieces in a row, just like before, and so then you'd have a tie.
So we don't check for if it's possible. We just play until it's
Yeah, you're like, okay, sure, whatever. You want to play with that many? Let's go.
Okay.
Right? We didn't do any like validation on the command line arguments. It is possible to do it. I just saved you from some time doing that. Because like some things that probably need to be asserted are like the number of rows, the number of columns, and the number of pieces to win all needs to be greater than 0. Right?
Right.
So, but like we don't do that. Oh no, I mean like I'm not going to give you bad command line arguments.
Oh.
Right? So you don't technically have to put that in. So, like, if you want to make it more robust, you should check that you're past exactly 3 command line arguments, and those arguments are all integers. Those arguments are all integers greater than 0. And if you really wanted to, which you wouldn't do for this particular problem, check to see if it's possible to win the game. Right? Because like, oh, if it's not possible, you might say like, oh, it's not possible, and just like quit right away. But we're not doing
Like, you'll have to stop by, obviously I will talk about this, but pretty much like what there needs to be is like two recursive calls. One call to go left and one call to go right. But you're calling yourself twice. One with one with the position to the left, and one with the position to the right of where you're currently at. Right, so the left and right being like how far you can move. So if you're currently at 10 and you can move 5.